Why do we need text-to-image model interpretability? To answer this, let me start with a simple example. I type in a prompt like a photo of a doctor, and the Stable Diffusion model happily gives me 4 nice-looking images. But if you look closely, they're all the same kind of person, same race, same gender, and even the same age group perhaps. The model clearly has opinions about what a doctor looks like, but right now that's hidden inside a black box. We really don't know which layers or heads are driving this behavior or how we might change it in a targeted manner. If I actually try to study this, I end up juggling a whole zoo of separate repos. One for patching attention heads, another for cross attention steering, another for sparse autoencoders. So nothing lives in one coherent library and requires constant plumbing. So what's missing is a toolkit. Instead of a dozen of disconnected scripts, you get a single library where you specify which model, which prompts, which modules you care about, and which interventions you want to try and which metrics you want to log. You press go and it runs a bunch of experiments for you. And at the end, you get a structured report that tells you for this task, for this data set, which layers, heads, or steering strength actually worked best with enough metadata that you or someone else can reproduce it later. Next, I show a demonstration of the toolkit. Now we want to do a localization experiment. So before that, we generate the original image. Before we proceed on to the experiment, we want to know how many heads are there at each of the hook sites. So we run it with a dummy input for just one inference step, and we got the number of heads. And in the next step, we are going to perform the experiments, which is ablation experiment on each of those heads. But before that, we also want to report the final output in WNB. And then here we define all our intervention objects. In this case, we are doing a scaling attention intervention, which takes in the accessors, which takes the selections, the heads. So this is a list of all the intervention objects. And in the next step, we define the metrics. In this case, we want clip scores to compare each of the steered image against the original image. And here in this step, we define all the intervention objects along with the generation parameters. So after that, we choose to run all the specs, all the interventions one after the other. We can choose to do it parallelly on different GPUs. Once it completes the experiments, we report the final output using the reporter class.